Good evening, everyone. Welcome to the third day of the video series of IA discussions. And today we will be discussing about the one more experiment on IA about something related to terminal velocity. Okay, let me share my screen. So today's topic would be how does the terminal velocity of a ball in a fluid get affected because of a change in variable. So usually in every part of my lecture series, what I do is I define only one variable. The rest of the variable, next variable, we need to decide and then define it. Okay. So which means the dependent variable, I know what is my goal. But how do I get that goal? What is the pattern it has been associated? That depends upon the research that I will be doing further. Okay. So therefore, we need to determine what is this value of the variable. Which variable would I be interested? This is the problem that I have posed. A very simple problem that I have posed across. And now I am going to do my research. Now, what are the variables that we can test that we need to look into? Now, towards it, the first one. So, what is terminal velocity? Terminal velocity is nothing but when an object is being dropped in a medium. So, what happens is the weight acts on it. So, as a result of it, the gravity tries to pull it downwards. And there's a drag because of the foreign molecules associated. And these foreign molecules will now try to give a buoyant force upwards. And if these two forces are equal, then definitely the net force acting on the object is zero. And as a result of it, the object moves with an uniform velocity. This is what it is. And we have seen these kinds of examples in parachute motion, or maybe when you have a motion of a ball immersed in water and it tries to gush up immediately. For some part of the time, it moves with an uniform velocity. Okay, because the net force is equal to zero, that means there is no acceleration and it should move in uniform velocity. And this is what you call as terminal velocity. The basic concept behind it is known to us. Now we need to look further or explore further as what is that we can look into it. Now, how do you narrow it down? So we need to look into this. Now, what is the research? Now, still we have not asked a question, okay, or we have not got an answer for this. What is this variable we are looking into? Okay, so first idea is that what variable can influence the terminal velocity? Size of the ball. For example, I take something like a container, I take a small ball and I drop inside it. Okay, then there's a possibility the ball can move slowly inside it, right? You would have observed this in oil, you have observed this in water, okay, wherever it is. So parachute also same thing happens, right? When a person is now made to come down, okay, from a certain height, he opens his parachute and as a result of it, yes, there's an air resistance which tries to slow it down, and as a result of it, it might be moving with a lesser velocity. Okay, and now if the velocity is a constant, you call this a terminal velocity. Now, does it depend upon the person? Does it depend upon the size of the ball? Because we are not going to push somebody from the building. Okay, we are going to do something like take a small ball, drop it in a fluid, and we are going to investigate the effect of it. Does it depend upon the size of the ball? Is the question is correct? Yes, definitely the question is correct, because if I have a very massive ball and drop it over there, so there is a possibility that it will fall down immediately, right? Does it depend upon the density of the fluid? Say for example, I am doing this experiment in a coconut oil. Now I conduct the same experiment in water. What will happen? So definitely in water, the same object which is floating inside it will immediately fall down, right? Because the weight is much higher. Okay, and the foreign molecules, the water molecules that are present there will not be able to give so much amount of push to the object, right? Density of the ball definitely depends upon the density of the ball. So this idea is correct. This idea is also correct. This idea is also correct, because you take a wooden piece and also a metal piece, an iron piece, and drop it inside. So one of them will float, the iron will definitely sink, right? So therefore it depends on the density of the ball. It doesn't depend on the weight of the ball. It depends upon the weight of the ball also. Okay, so this idea is also correct. Okay, then does it depend on the shape of the object? Let us say for example, I take an iron object, okay, and then put it across. Now what I do is I don't take an iron, I take something like an iron nail. Okay, I take the same iron, but I take an iron nail, I take an iron sheet. Okay, for example, this is what we ask, like why do boats float? Okay, and why does the iron needle sinks into? Okay, in a similar way, is it that I take something like a sphere type of molecule, I say a sphere type of object, take a sphere type of object like this, drop it inside the solution, it moves faster. And the same object, okay, I take this one in the form of something like a spear. Okay, this is spear, this is not spear, this is spear, this is SPHAR. Okay, and this SPHERE. Okay, so I do something like this. So what happens? Which one will come faster? Or is it both of them will definitely sink? Will they experience the terminal velocity or not? Might be this will experience acceleration, this might experience terminal velocity. So is this right or not? Is the question correct or not? Okay, we'll truncate it later on. Okay, first let us ask what possibilities are there for us to conduct the research. So therefore, this is also correct. Impurities in the liquid. We can ask this question also. When you say impurities in the liquid, what do you mean by impurities? I can put sawdust into it. I can put charcoal powder into it. Now, how much will you put it? Okay, how do you measure that value? Okay, and if you drop something like that over here, then maybe it will get dissolved. It may not get dissolved. If it doesn't get dissolved, it can get clustered into it, can get stand up at one point. Okay, as a result of it, this you cannot measure anything. So therefore, this idea is not so good. Okay, because when you talk about independent variable, these are all the independent variables. Okay, I need to measure it in a systematic way. Okay, I should not just jump from one value to other value. So here, impurities will not have any meaning to me. Okay, so therefore, this I don't think, okay, this will be useful. So I will just discard this one. Out of 5 ideas, 4 ideas are good enough for me. Let me go to the next one. Next is height of the drop. Now let us say, for example, I have the container here. I have the container here. Okay, I drop it from here. I drop it from here. Which object, the same object, will achieve terminal velocity? If I ask this question, then definitely I don't have any idea. I need to look into it, right? Because when the object which comes from here will have a larger weight, will have a larger force over here, or not larger force, sorry, larger velocity over here when it reaches, right? Because the mg force is same. Here also mg, here also mg. Here it will have a larger velocity over here as it splashes it. So I might think might be the object will push against the water molecules and immediately gush inside it and reach the point very faster as compared to this one, right? So this is a possibility. We do not know. We need to investigate. Okay, so this is also a possibility. Angle of drop. Now what I can do is I can take an object like this. I can take a big container like this. I can take a big container like this. Okay, and then what I can do is I can take the object here. See, this is the vertical. With respect to this, I can drop it like this. I can push 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 it in any direction. Now, when the directions are changing, is there a possibility that the terminal velocity will change? We do not know. Okay, this could also be a question. Then homogeneous and heterogeneous solution. Now, let us say, for example, I have a container. I have a container. And now I put something like here, I put, let us say, coconut oil. Don't ask me whether coconut oil is favorable for me. Okay. The easiest thing that comes to our mind is coconut oil. And next, maybe I'll put something like groundnut oil, or gingerly oil, whatever it is. Okay, and I mix these two together. Okay, let us say I add something like 50 ml of this one here and 50 ml of this one over here. Okay, mix them together. And I ask the question, okay, it's a homogeneous, okay, how does the terminal velocity depend? And when I add heterogeneous, then what happens? Right? I can ask this question also. All these questions are good questions. That means how many questions we have now? See, we thought we will start with only one question, but unfortunately, it's so out of which 9 questions. Okay, one of them is not a feasible one. We left it out, and we got 8 of them correctly. Now, how did I arrive at all this? Okay, see, the interest is not at something like looking at the topic over here and then start to work on this. The interest is tomorrow when you look into this video, you should also get an idea as how to coin a problem. Okay, I am just showing you how did I arrive at a final result. Okay, it is the journey is very important. It is not, okay, what is the final result? If it was only the final result, I would have just said, okay, like other videos, okay, this is the title, I'm going to start with this. Okay, so which may work for me. So 50 students might look into it, and as a result of it, 10 students might take up the idea, and all the 10 of them will do the same topic, and ultimately you might not, when you submit the exam, you might get the same topic. So yeah, during the time of examination, right? So don't do it. Okay, so do not copy this topic. Try to think based on these lines. Okay, have a PPT like this. Okay, not necessary that you should have the same structure. Okay, you can take even a notebook, a pen and pad, and then start writing this. Now, how do you get all these ideas? Brainstorming. Okay, so do a brainstorming, okay, between your peers, between your teacher and yourself, or maybe between the students, and ask several questions. Some of these questions could be good enough, some of them could be not good enough or silly ones, but anyway, I'll put all of them. Okay, so you have a bunch of questions, a handful of questions, and then you can proceed further. Now, next is you need to narrow down these ideas into focused questions. So how do you narrow it down? Next. So what did we do in the earlier videos? We looked at what was the available apparatus, and based on it we proceed. Okay. Now let us look at the available apparatus. If you want to find the size, what do you mean by size? Radius. Okay, so how do you find the radius? You can find out using a spirometer or maybe a vernier caliper. You would have done this in your labs. So therefore, this you can do it. Okay, so this is available. Density by displacement method. What do you mean by displacement method? You take the mass of the object, put it in a weighing machine. Then take that object, put it inside, let us say 500 ml of water. Okay, and then find out what is the volume of water getting displaced. Let's say 10 ml has been displaced. Then you get the volume. Mass by volume gets you the density. Okay, you can get the density, you can vary that, you can get the density over here. Then weight, can you measure the weight? You can measure the weight using weighing machine. Height, meter scale, you can do it. Then angle, you can do it using a protractor. Homogeneous or heterogeneous mixing volume, all of them are correct. Which one will I choose? Shall I choose, okay, anything randomly? No. Okay, there's one more test which we need to do. First thing is, we thought we will vary any one of them, right? So we will vary any one of them. Size, can you measure? Can you vary this? You can vary. Okay, let us say for example, if there is a shop which is available for you, which gives you the radius of these metallic balls. I've seen this in Amazon. Okay, so one of my students who did it earlier, I had also done an experiment like this. Okay, so there are something like 12 different balls, 12 different metallic balls which are available, okay, of different radius, and you can purchase this one and go with it. So size is always a feasible one for me. It's always a feasible one. Density, you want to vary the density of the liquid. The moment we talk about density variation, how do we vary the density, right? So you can take coconut oil, you can take groundnut oil and so on, but we are talking about an independent variable. What do we need an independent variable? In an independent variable, the interval of differencing between one variable and the other value should be the same, which means that if your density initial, the first density of the fluid that you have taken is, let us say 1 gram per centimeter cube, the second one could be 1.1 gram per centimeter cube, third one could be 1.2, fourth one would be 1.3, 1.4 and so on, so that when you draw it in a graph, you get a meaningful solution out of it, right? So therefore, it should not vary much. So that is it should not be something like 1 gram I have taken, 1.8 I have taken, 2.3 I have taken, okay, 21.7 I have taken. No, this is wrong. Okay, don't do this because we do not know how do the objects behave. Okay, so as a result of it, do not take something like this. Always it's better, okay, in this case it might work, but it's always better to take something like the difference between any two liquids densities should be a constant or fairly a constant. Let us say you got one as 1 gram over here, second was 1.2, third one as a 1.5. Good enough, no issue at all. Okay, though the difference is 0.3 over here, doesn't matter. It should not be very, very large. That's what I said. Okay, and then before density, so this is also fine. Weight, you can do it. So we have seen that most of the parameters are seen to be measurable also. You have available apparatus. Now the next question we need to ask is it that, okay, if I do this and this, do they mean same to me? Okay, are there any connected parameters between them, common parameters? Now let us look at this. Density, what is density? You need to do a little bit of math over here. Density is nothing but mass by volume. Okay, now how do I write mass by volume? Mass is equal to, so this is mass, and what do I do is, if it is for example a sphere, so what do I do? I can now write this as density of the sphere multiplied by volume of the sphere divided by volume of the sphere. I can do something like this also. Okay, and therefore I can find out what is I'm sorry, we're doing a mistake over here. Okay, so density equal to mass by volume. Okay, so you have to find out the mass, you have to find out the volume. You can do it this. See, it again depends upon, this is mass is same, mass you can measure, it's a value, and then r cube. So here it depends upon the r cube. So this cannot be an independent variable. It only has to be a dependent variable. This is a calculatable variable. That's what I want to say. This is a calculatable variable. So therefore, I'm not going to use this one over here. I can use radius over here. Weight. How do you measure weight? You can measure the mass of the object, not the weight. M into G will not be useful. So I will replace this weight by mass. Replace by mass. Then height. Height you can always measure. So this is an independent measurable variable. And then angle you can always measure. Homogeneous and heterogeneous mixture, you can measure this also, but we do not know whether this will work or not. Maybe, okay. So if I say 10 ml of coconut oil and 80 ml or 90 ml of groundnut oil, you are using it. There's a possibility that you put it like this over here. Put it like this over here. This is your 90 ml and this is your 10 ml. 10 ml. So there's a possibility that this will now undergo something like where the terminal velocity from here to here. Okay. which means, let us say, for example, this is if this is 90, this could be 70, this could be 30, this could be 0, and this is 10 over here. So it means you will get answers for, okay, almost all of them. So how much it is? 0, 1, 2. For the next 3, 4 readings, you will get terminal velocity. And the moment it comes over here, okay, you may not get the terminal velocity. So again, 50-50, okay, you might get it. But of course, it's worth investigating to look into it. There's one possibility if the two liquids do not get mixed. But if there is a possibility of two liquids getting mixed, okay, then definitely, okay, then it could also change. But anyway, this is also an interesting problem. You can do this also. Okay, now what else can we see? So therefore, now what we have is we have radius, mass, height, theta, and this one. Now still we will look into it. What else can we do? Now this, I always accept this. Density, I will not go for it. Calculatable variable. Weight, I will not go for it, but I can always go for the mass over here. Okay, then height. Height is also a good one. Theta. Now theta, what happens is in theta, you have something like this. You have a barrel over here, so it's a liquid over here, and you have the object. You give a push over here. The moment you give a push, there's a possibility this will go hit this container vessel and then come down like this. So as a result of it, your terminal velocity cannot be calculated properly. I don't want this to be having any other influences. So therefore, this also you will exclude this. And this I really doubt because nobody has done it. Okay, I should be careful because I conduct an experiment. Okay, I'm not able to arrive at any plausible results. Okay, then I should also be able to say why it did not work, what is the justification behind it. So I would also not to go behind this also. Now we have size, that is radius we have, and then mass we have, and the height we have. All the three we have. Now still I'm not able to decide which one I will go. So I can either choose one of them. Okay, that's the easiest way. But still if I want to drill down, so what I will do is I will do something like look at the math behind it. What is the math? So what are the forces acting on an object? This is the ball, iron ball. mg is acting like this. Then fb is acting like this over here, or maybe the viscous force fv is acting like this, and this is given by mg is equal to 6 pi eta v terminal, and there's one more buoyancy force fb is also acting like this, plus fb over here. So when you relate this one over here, you will get something like terminal velocity is proportional to some density proportional to some r square. You'll get a big expression. I'm not going to do this. You do all these things. Okay, so you get this one. So therefore, you see it is directly proportional to density is proportional to radius square. Somewhere when terminal velocity increases, when radius increases, terminal velocity will increase. That's what we can come to know. Okay, so therefore, based on this, I will exclude all the rest of them also, and I will go with this because I have a mathematical relationship connecting this. Okay, so why should I bother about the rest of them? That's what my question is. If I already have something in hand, if I have a proper math with me, then definitely I'll go with it. But this would be quite interesting. Okay, I'd be more quite interesting if I look at this and this. Okay, so if I observe that someone else has already worked on it, then definitely I'll go for this and this. But math is a problem. Okay, so you can look into this also. Okay, next. Now formulating hypothesis. If the radius of the ball increases, now I have trickled down into radius of the ball. Then you need to measure the velocity. Because so far we've been talking only about the velocity, and suddenly why I have put the time of fall. The reason is because how do you measure the velocity? Measuring velocity is a headache. You don't have a velocity meter, run that to inside the fluid. We can do it by something like your video analysis. Okay, but how far? Okay, it's a question. But of course, if you use technological innovation, you can do with it. Okay, but to be on the safer side, everyone will not be able to take a video and do everything. But to be on a safer side, so what I can do is, this is what is the apparatus look like. This is how it looks like. So this ball will now try to come over here. Okay, the distance has been measured. The time, you can measure it using a timer. Okay, so therefore, I can usually find out what is the time taken by the ball to start from here and to cross this boundary. So this is A and B. So I know what is the distance over here and I know what is the time taken over here. If the time taken is the same for all the balls and I assume there is a terminal velocity here, then what I can do is I can say this is my distance. Distance by time will give me the terminal velocity. I can easily get this. So therefore, time of fall would be very important for me. I can find out this is the only measurable variable that I have. The rest of them are all fixed. And radius of the ball. Radius of the ball is nothing but the balls that I am going to drop. I'm going to take, let us say, five balls of same radius, say 1 millimeter radius. I'm going to drop it into the coconut oil, and as a result of it, let us say the distance over here is, let us say, something like around 40 centimeter distance over here, wherein this point is something like 30 here, this point is 70. The first 30 centimeter I leave because it has to settle down. I just leave it across, and therefore I'm going to measure what is the displacement happening, what's the time taken by it to cross this distance. So I get this value here. If it works, then it's fine. Okay, so therefore, why do you expect and why mention all the reasons? So we have come to a hypothesis part. Okay, next what I do is, we have looked at what is your independent variable, what's a dependent variable. What's the independent variable? Independent variable is the radius of the ball, and then we need to mention in what way are we going to measure. Maybe we have 1 millimeter ball, 1.2 millimeter, 1.6 millimeter, 1.8 millimeter, 2.2 millimeter. See, again, there's a jump over here, but anyway, there's no other way. I cannot design the balls for doing this one, so therefore I have to go only with what is available. I'll take up these values. Then time of fall, which can be measured in seconds, I can do this. Then density of the fluid. Okay, I'm going to find out what is the density of the fluid. If I'm using coconut oil, use pure coconut oil. Castor oil, use pure castor oil. And that also, okay, look into it, like, okay, which one you can use it. And then density of the ball is remaining a constant. So all this we take it across. Then relevant math concept. I had already told you what is relevant math concept. And then you're going to use terminal velocity formula. You're going to write down the Stokes formula, balance of forces. You're going to use it. Use your FBD diagram, use the appropriate diagrams, use the images. Okay, take photos, multiple photos of the experimental setup. Okay, show in the photo, like, okay, what is the object, what is the force acting on it, where is it acting. So mention everything. Okay, it should be in such a way that when you leave the lab and someone else comes and looks at your report, they should be able to do it once again. Okay, that should be the level of confidence your experimental details should provide. Okay, some of them, when they do the experiment, what they do is they don't even put the diagram. So I have to scratch my head to see, okay, what is the way how he has done it? Has he generated the data using ChatGPT? So these kinds of questions will definitely come as an examiner. Okay, so therefore you have to be very careful while doing all this. Then graphs. Okay, look at the type of graphs that you get. Okay, so these are the type of graphs you get. Okay, you get something like this over here, and you get something like a constant over here. Do we get this part? We do not get this part, because this is something which you get it only when you consider a fall from a certain height, and this is for a parachuting action. And this is what is a kind of graph you get. Believe me, when you do an experiment, you might not get this region at all. Okay, you might get only this region, because the time taken by the ball to reach over here could be hardly 2 seconds. If it is only 2 seconds, then it becomes very difficult. Then what you need to do? Okay, you need to go, and you cannot use a timer. You need to go for a video analysis. This is what will happen. Okay, then next is, how do the formulas connect to your variables? You have to mention all this clearly. Okay, next. So what is the apparatus and setup that you need? This is the kind of apparatus you need. You need to have something like a container, and you are going to drop the object over here, and as the object comes down, okay, you're going to find out what is the time taken by the object to reach or to travel between any 2 points over here. Okay, what equipment you need, what is the example equipment? You need to have a viscous fluid, metal balls of different radius, you need to have a timer. Maybe I will add a mobile phone, then you need to have a tracker software, right? In the previous 2 videos also I had mentioned how do you use a tracker software. There are videos available for you to look into this and understand that. Okay, next is, this is an example which was done on the same experiment. Okay, whatever I'm mentioning, I just looked into the web and I found out there was somebody had already done this. Okay, and the data table is also available like this. So you see micrometer readings, the readings of the radius of the ball is being given over here. The average diameter is calculated. The average time of fall is being seen for a given distance, 0.68, 0.59, 1.23, 2.33, and so on. And the terminal velocity was computed. Is there a terminal velocity over here? See, terminal velocity is seen to be varying over here. It is not a constant. Though we think terminal velocity should be a constant, it's not going to be a constant over here. It's going to change. Then the radius. Okay, so you can estimate what is the radius square. Okay, and then you find out what is the relationship connecting these two. I'm sorry, these readings are not there. Okay, and then you put across the uncertainties, okay, and then there's also launch height is not there. It's done for the previous one. Okay, so I just copied that slide and put it over here. And so what you can have in your data table is something like this. Since I have put this one here, I did not change anything over here. Okay, so this is what is a table. So remember, whenever you are writing a data table, very important thing is that it should have headers. Most of them make this mistake by not putting the headers. And secondly, you should put the units appropriately. I think this is not a IB based experiment. Okay, for some CBSE or anything. So the lastly, put the uncertainties. Very important. Okay, plus or minus, what is it? Okay, and then you need to mention about the propagation of uncertainty. And as I told you, okay, so what do you observe here? Okay, any infographic that you have, you should mention about what do you observe from the data table. Don't say I'm going to write all this in the conclusion. Immediately after the infographic, you need to mention, okay, what is it you observed it. So for example, you can say here that as the radius starts decreasing, the terminal velocity also starts decreasing, right? See, radius is decreasing over here, terminal velocity also decreasing. I do not know in what way does it decrease. Is it square of it or cube of it? Nothing has been known to you. I'm just going to mention this one here. Okay, and then maybe once I get a plot, okay, I might get something like a non-linear plot or a linear plot. I may get a plot like this. When I get a plot like this, you need to ask about, you need to talk about, okay, why do I get this intercept, right? So let us say if this is your radius and this is your velocity, why do you get this intercept? What does it tell you? What does this distance tell you? Because you have taken a variable, you have taken the radius to be something like r is equal to, let us say, 1 millimeter, and your velocity cannot become 0 here. If it becomes 0, that means something is wrong. Okay, you would have got a plot like this. You would have got a plot starting from here. Okay, and don't ever stretch it this one backwards over here. Don't try to connect it like this. Okay, so every graph need not pass through the origin. Remember this. Okay, because in your data analysis paper you would have thought if it is a line of best fit, okay, it should pass through the what you call, if it's proportional or inversely proportional, you should pass through the origin, but that's not required over here. So whatever data you get, plot the graph appropriately. Okay, next, then comes your evaluation. So in evaluation, what will you talk about? You will talk about the sources of uncertainty and error. What is the source of uncertainty? You took the sphere, the radius was certain, no issue, and then you took a fluid, the density of it was same. Now, how do you ensure density is same? Whether it is always a homogeneous mixture, or maybe there could be some impurities which are unknown, so that could also be possible. And you are conducting the experiment in a day. Okay, so as a result of it, because of temperature, density might change. If the density changes, then FB might change. There could be impurities present into it. Okay, all this could be present over there. And maybe when you put across the tube, okay, when you put across the tube like this over here, okay, so maybe this is not exactly flat, okay, or maybe, flatness will not come into. So now there is a possibility there could be some vibrations, or maybe when you dropped it over here, so this came and hit this one like this, okay, and it went over here. So these are some of the uncertainties possible. Limitations of your method. What are your limitations? You need to mention about the limitations over here, mentioning about, okay, so this experiment could be done only under such and such condition. And if this condition is changed, then definitely you may not get the appropriate result. Then suggestions for improvement. Okay, if you find that something is not so good, for example, you would have taken a tube, a test tube, a beaker or a tube, which is only something like around 50 centimeter long, and you would have observed, you would have thought that terminal velocity is happening over here, maybe for a time of 10 centimeter. And the time the ball crosses is 10 centimeter, okay, you would have had something like human trials. Anything that is referring to something like usage of a timer, okay, there is a human error there. You need to be careful to mention that human error. Okay, so as a result of it, maybe you would have used a sensor. Maybe if you are not use a video tracker, you can mention that you are doing it using a video tracker and so on. And then strength of your conclusion. Okay, so this comes from once when you have a math. That's what I always say. You should have a math for your IA before you begin. Okay, so do not say, okay, I'm going to start with it because I know what is my RQ, what is my hypothesis, I have all the apparatus. But look for the math, very, very important, because this is where it becomes very important. So what you can do is you can compare your experimental results with the theoretical results. And then you can say, okay, where does it go wrong? What is going on wrong with this? Okay, there's a possibility that the radius of the ball that you have taken is not exactly spherical. Okay, so radius might change here and there. So therefore, the density of the sphere that you have taken may not be a constant. Okay, so these kinds of things you can add it in your the evaluation. Okay, finally conclusion. So what is the conclusion you have? So you can say clear and direct answer to the RQ. What is your RQ and does it support your RQ? Okay, so you have to mention that. And then interpretation of the process data. So what is the process data you have got and how do you interpret that? Okay, you can mention this, and then you can, what you can do is you can use also the calculated range or using the simulated data. If there is a simulation available, simulation tool available, you can take up that value, that tool, okay, and then you can say this is what has been done on the same this one, and we can calculate it. A reference to associated uncertainties. Okay, so what is the uncertainty in it? Okay, and how do you tackle that? How do you did you do something like what you call in an uncertainty, propagation of uncertainty, to go into it? You need to look into it. Link to the scientific theory. If someone has already done that, okay, then link to it. Sorry, this is accepted model is r square into v equal to constant, which is no, I'm not sure. Okay, sorry, I'm sorry. This is not r square into v. Okay, so look into that and find out using Stokes law, using the math you can mention to this one. And you can also look at, okay, whether there are any reference to the what you call the Stokes law in the scientific literature. Okay, see somewhere we look not at your experiment. See, your entire IA is not looking at your experiment. See, people have already done this experiment. They know what is the variation with which one. The interest here is that how do you look at articles? How do you get those articles? What kind of articles are you referring? Have you read through that article? What is it you understood from a research article? The interest is to inculcate the research discipline in you. So far, you had been learning everything only from your textbook or maybe from a video. But okay, what you have to learn is by looking into the research paper. Then source the citation that is being citable, that's traceable. Okay, so therefore, see, don't just give this article. Say many of them do the same thing. What they do is they take up this particular title of this, okay, put it in ChatGPT or any other AI tool and ask, get me citations out of it. This AI tools will definitely give you some citations, but none of them, most of them, not none, most of them may not be correct. Okay, and especially ChatGPT does all these things. Okay, so therefore, do not believe into all this. And if at all, if you get it across also, look into it, okay, search for it, look into it, whether the cited article, what it gives you and what you are looking into it, okay, whether okay, it is matching with each other. Can you really take up, see, don't take up any research article for that matter. Okay, say somebody, while they were doing this experiment last year, I found out that, okay, they had given something like finding out the viscosity of blood, okay, using ChatGPT. Okay, but how does the viscosity of blood actually come into? Just the search terms will not be useful. Okay, we are not asking you to find out what is the key terms. We are not asking you to become a digital marketer here. Okay, a digital marketer needs to do the SEO. You are not asking to do this one here. Then statement about how consistent the data is with the scientific context. Whatever you observe in the scientific context, okay, how good is your data? So what is that it reveals? So everything that you observe in the data, you observe with the process data, okay, and then what is that you can conclude from it? So mention also here. So this is how, okay, you finally are able to report. So with this, I think I have just given you a complete overview of how to conduct an experiment, like finding out the relationship connecting the viscosity of a fluid, or so not viscosity, what do you call the radius of the ball along with the terminal velocity, or maybe terminal velocity is a bonus that you get, right? Maybe with the what you call the time taken by the ball to fall across, okay, where does the forces become zero? So that's what we have done so far. So if you really like this video, do like, share, and subscribe to my channel so you get more updates. And we'll see you back in next video, that is tomorrow. Thank you once again.